Hi everyone. Today I'm going to be looking at a couple of tension questions relating to grade 11 physics. I wanted to look at some tension problems because I have noticed that these kinds of questions can be trickier for students. It seems like because there isn't a very specific defined way to solve for tension, that it can be a bit confusing. For example, we always know how to solve for the force of gravity, right? We just have mass times our gravitational acceleration, which is usually 9.8 meters per second squared. But with tension, sometimes we have to think a little bit outside the box in terms of what's going on in our specific scenario. So let's jump right in to question number one. What are the two tension forces in this scenario? So the scenario is we have a box weighing 5 kilograms, and it is suspended in place by two ropes attached to the wall. So immediately from this description, suspended in place means that there is no acceleration happening. Therefore, my F net must be 0. What I also know is that there is a gravitational force going on here. So let me plug in 5 kilos and see how much force is downwards. 5 times 9.8 will give me 49 newtons. So I know that there's 49 newtons of force because of the mass of this object, and that is straight down. But since the box is suspended, what must be happening is the ropes are actually stopping this force from causing acceleration. Therefore, there must be an equal and an opposite force due to the ropes. So what I'm actually going to do, I want to focus on this specific rope first. So let me draw that out here. So this rope is actually attached to the box at a 30-degree angle from the horizontal. And that's a very important number because in a question like this, we are going to have to use angles to solve for our x and y components of a vector, in this case being the force. So let's think in this scenario here. We need 49 newtons of force upwards to balance out the gravitational force. This rope is completely horizontal, so it doesn't have a y component, but this one does. Therefore, the y component in this rope must be 49 newtons in terms of tension, because that's the only way we're going to balance out the gravitational force. So I want to know the overall tension force in the rope, which is going to be here. This line here is representing our rope. So we can use some trigonometry to solve for that number. So when we take a sine of an angle, we need the opposite over the hypotenuse. And in this case, our opposite side is known. We know it's 49 newtons. And we are solving for our hypotenuse, which is tension. So I'm just going to rearrange the question to solve for tension. So t is going to go here because I'm going to multiply both sides by t. And then I'm going to rewrite my equation. And now we just need to get rid of sine on this side. So I'm going to divide sine 30 on both sides. And it turns out that we get a nice clean number. The tension in our rope is 98 newtons. So we knew that the y component was 49 newtons, but the overall tension, right, that's combining the x and the y component, would be 98 newtons at this angle. So that's the first half of the question. Now we need to think about our other rope. Because our other rope is just horizontally attached to the box. So it doesn't have to do anything with regards to gravity, but what it does need to do is it needs to oppose the x component of this rope right here, right? Because if we had this rope on its own, okay, the y component is taking out gravity, but then we've introduced an x component of force, which we need to oppose. So if we can solve for this value, we know that the tension in our second rope will be equal and opposite to this one. So you have to go back to trigonometry. This time, let's do tan. So same angle, and with tan, we would look at opposite over adjacent. Opposite is still 49. Adjacent is what we're solving for, and that's the x component of our force. So moving x over to the other side, and then dividing out our tan 30. We get an approximate value of 84.9 newtons. So to wrap it up, let's go back to our diagram. We can say that this rope has 98 newtons of tension force. And if you wanted to be more specific, because force is a vector, we would say it has 98 newtons of force 30 degrees north of east. Over here, we would have 84.9 newtons of force exactly west. So hopefully that wasn't too bad. Now I want to move on to our second question, which is going to make us think a little differently about a tension scenario. So I have a very basic pulley system here. I have a mass of 10 kilos attached to a mass of 5 kilos by a rope. So question number 2 is, what is the acceleration of the following system? And also, what is the tension force in the rope? So let's do one thing at a time. Let's look at acceleration first. So what I want to do is think about the forces acting on the system. So I can tell right off the bat that I have the force of gravity from this 5 kilogram mass. So let's see what that is. Should be the same number we had in our first question, because we also had a 5 kilogram mass. Yep, we got 49 newtons. So what I find pretty common with students is they'll actually get stuck here because they think, okay, I have 49 newtons of gravitational force downwards on this 5 kilogram mass. That means that I should have a tension force of 49 newtons upwards to counteract that. But we can't necessarily do that in this scenario because of this second mass here that's been attached by a rope. Because what we've done is we've created a larger system. And so in order to figure out tension and also acceleration, which is the first part of our problem, we need to think of the masses together. But this is still useful, the force of gravity that we've solved for. Because the force of gravity in this scenario is going to be our F net, because it's really the only force that can cause motion to happen. This also has Fg, but we have a normal force that's counteracting that. There isn't any friction, so we don't have to worry about that. Here we would also have a tension force from the rope. And the tension here and the tension here will be equal to each other because the tension across a rope is the same. But we can't necessarily just assume that it's the same as our force of gravity from this mass. Anyways, I am getting ahead of myself. Let's stick to acceleration. So, F net in this scenario is purely Fg, and that's 49 newtons. But let's think about acceleration. Acceleration is going to depend on the mass of the system. So if I have 49 newtons of a net force, that means that this needs to be divided by both of my masses to solve for acceleration. So how did I get this equation? Let's think about F equals ma, specifically F net. If I'm going to rearrange to solve for A, I need to move my mass over here. But I need to consider both masses together because they're both attached to the rope and they are both part of the system. So if this box here is accelerating at a certain rate, this box here must also accelerate at the same rate. So if I move mass here, I get F net, which in this case is gravity, divided by m1 plus m2. And that is this equation right here. So all we need to do now is plug in our masses. So 49 over 10 plus 5 equals acceleration. That will be 49 over 15. And acceleration looks like somewhere around 3.27 meters per second squared. All right. So the most important part of that first problem, or the first part of the problem, is understanding that we're using the masses together to solve for acceleration. We cannot use this mass by itself to solve. That wouldn't work. But okay. Second part is a lot simpler. We need to think of the tension force in the rope. So what I want to do is I want to look at the first mass, which was 10 kilos, because the only force acting on this mass, well, not necessarily the only force, we do have Fg and our normal force, but those cancel each other out. So the net force is coming from our tension. So if I just write out F equals ma, F is going to be our tension force. We know mass, which is 10, and we just solved for acceleration. Therefore, the tension in the rope is going to be 32.7 newtons. So if we go back here, I could just write that as the tension force. And that would also be the case down here, just in a different direction, right? And that's why this 5 kilogram box can accelerate in this problem, because Fg was 49. Obviously, that is greater than 32.7 newtons. We have an F net greater than 0. And that's what allows acceleration to happen. So, thank you for watching. I hope this was helpful. I will be thinking of other tension questions to work through because I know that they can be tricky, and the more practice you can get, the better. So thank you for watching, and I hope you have a great day.